Throughout human history, the moon has been our constant celestial companion, inspiring myths, legends, and scientific curiosity. From ancient civilizations who saw gods in its craters to modern scientists uncovering its deepest secrets, the moon continues to captivate us. Today, we're diving deep into the most extraordinary discoveries about our nearest cosmic neighbor, revealing mysteries that will reshape our understanding of space exploration. Remember when everyone thought the moon was just a dry, dusty rock? Well, that assumption was completely wrong. In what might be one of the most significant space discoveries of our time, scientists found water, and lots of it. But where exactly is this lunar water hiding? Let's start with the poles. In permanently shadowed craters near the lunar poles, NASA's missions discovered significant deposits of water ice. These craters, never touched by sunlight, act as cosmic freezers, preserving water ice for potentially billions of years. Just imagine, these dark craters might hold the key to future space exploration. But here's where it gets really interesting. Scientists made an even more surprising discovery. Water molecules exist even on the moon's sunlit surface. This finding completely contradicted our previous understanding of lunar chemistry. The NASA SOFIA telescope confirmed water molecules in lunar soil, challenging everything we thought we knew about how water could survive in such harsh conditions. How does water form on the moon's surface? Here's a fascinating process. The sun constantly bombards the moon with high-energy hydrogen ions, what we call the solar wind. When these ions crash into oxygen-rich minerals on the moon's surface, they create hydroxyl and water molecules. It's like a cosmic chemistry experiment happening right above our heads. Looking at the moon's quiet surface today, you'd never guess its explosive past. Recent research has completely rewritten our understanding of lunar volcanic activity. Scientists now believe volcanic activity continued until about 1 to 2 billion years ago. That's several billion years longer than previously thought. The evidence lies in the massive lava plains visible from Earth, the dark areas we call Maria. But that's just the surface story. Beneath these plains lie vast networks of lava tubes formed by ancient flowing magma. These tubes aren't just interesting geological features. They could be crucial for future lunar exploration. These lava tubes could serve as natural shelters for future lunar bases. Why are they so perfect? They provide protection from 3 major threats to lunar exploration: cosmic radiation, extreme temperature fluctuations, and micrometeorite impacts. Some of these tubes are large enough to hold entire cities. Here's something that shocked the scientific community. The moon once had a magnetic field as strong as Earth's. How do we know this? Apollo mission samples contained magnetic signatures that could only have been created in the presence of a powerful magnetic field. This ancient magnetic field was probably generated by a molten core about 4 billion years ago, similar to how Earth's magnetic field works today. But then mysteriously it disappeared. This disappearance is one of the most intriguing puzzles in planetary science. While the moon no longer has a global magnetic field, it still holds some magnetic secrets. Scientists have discovered areas with local magnetic fields called magnetic anomalies. These areas might have been created by ancient asteroid impacts or volcanic activity, and they could prove invaluable for future lunar settlements by offering natural radiation protection. The moon's origin story reads like a cosmic disaster movie. The leading theory, known as the giant impact hypothesis, suggests that about 4.5 billion years ago, a Mars-sized object called Theia crashed into the early Earth. The debris from this colossal impact eventually coalesced to form the moon. This theory explains many of the moon's unique features, but it also raises fascinating questions. For instance, why is the moon's composition so surprisingly similar to Earth's? This puzzle has led to refined versions of the impact theory and continues to challenge our understanding of planetary formation. About 4 billion years ago, the moon and inner planets experienced what scientists call the late heavy bombardment, an intense period of impacts from asteroids and comets. The moon's surface still bears the scars of this violent epoch, providing a preserved record of this crucial period in solar system history. Speaking of impacts, the South Pole Aitken Basin is one of the largest impact craters in our solar system. This massive crater, about 2,500 kilometers across, is so deep it exposes materials from the Moon's interior. It's like a natural drill hole into lunar history. Perhaps the most provocative discovery is the presence of organic molecules on the Moon. Scientists have found traces of complex carbon compounds in lunar samples. While this doesn't mean there's life on the Moon, it raises intriguing possibilities about the distribution of life's building blocks in our solar system. These organic molecules could have multiple origins. Some might have hitched a ride on comets and asteroids, while others might have formed during the Moon's volcanic period. This discovery has important implications for our understanding of how life's precursor molecules might be distributed throughout space. Let's talk about one of the most underappreciated aspects of lunar exploration: moon dust, or regolith. This isn't your everyday dust. Lunar regolith is incredibly fine, sharp, and clingy. It's also packed with potential resources. Scientists have found that this dust contains oxygen, metals, and rare earth elements that could be extracted for future lunar operations. The Moon is entering a new era of exploration. NASA's Artemis program aims to return humans to the lunar surface, this time to stay. But they're not alone. Space agencies worldwide are planning lunar missions. China's Chang'e program has already made history with the first landing on the Moon's far side. The Lunar Gateway project represents unprecedented international cooperation in space exploration. This small space station orbiting the Moon will serve as a stepping stone for both lunar surface missions and deeper space exploration. The Moon's resources could revolutionize space exploration. Water ice could be split into hydrogen and oxygen for rocket fuel. Rare earth elements could be mined for use in electronics and energy systems. Helium-3, rare on Earth but more abundant on the Moon, could power future fusion reactors. Modern lunar research uses an impressive array of tools, from orbital spectrometers that can detect mineral compositions to ground-penetrating radar that reveals subsurface structures. Our understanding of the Moon grows more sophisticated every year. The Moon's stable surface and lack of atmosphere make it an ideal location for astronomical observations. Future lunar telescopes could peer into space without atmospheric interference, potentially revolutionizing our view of the cosmos. As we continue to unlock the Moon's secrets, each discovery brings new questions and possibilities. The Moon isn't just our natural satellite. It's a testament to our solar system's violent past, a potential stepping stone to Mars and beyond, and perhaps the key to humanity's future in space. Recent lunar discoveries have shown us that even after centuries of observation and decades of space exploration, our celestial neighbor still holds countless mysteries. As we prepare for a new era of lunar exploration, who knows what other secrets we'll uncover? The next time you look up at the Moon, remember, you're not just seeing a familiar face in the night sky. You're looking at a world of undiscovered wonders, a future home for human exploration, and perhaps the gateway to humanity's greatest adventures yet to come. This is more than just space exploration, it's the next chapter in humanity's greatest journey. And as we continue to uncover the Moon's secrets, we're not just learning about our cosmic neighbor, we're learning about our own origins, our place in the cosmos, and our potential future among the stars. Thank you so much for watching. If you enjoyed learning about the Moon's incredible mysteries, don't forget to subscribe and hit that notification bell. Join our community as we explore more fascinating secrets of the cosmos. See you in the next video.